With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students. So in this question, you have been told that which of the following arrangements are correct with respect to the property of the compounds indicated in the parenthesis. Okay, you have to tell the correct options. Okay, and see, the first one is the carboxylic acid group. Okay, they are the different types of carboxylic acid, and you have to tell about their acidic strength, that whether these are arranged in the correct acidic strength or not. Second, again carboxylic, but with the halo compound, halo groups, so again acidic. And then we have this mixture of alcohol and the carboxylic acid, then again here acidic. And then we have to tell here basic strength for the nitrogen groups. Okay, so let's get started. What and see, the very first thing you should know, that when we compare the acidic or the basic strength, right, what do we do? That we have an acid over here for which you have to calculate the acidic strength. We convert the acid into the conjugate base. What does mean by conjugate base? Suppose we have HCl, H2SO4, right? H2SO4. So it will lose its H positive ion, right, to form H positive plus HSO4 negative ion. Okay, so this one is responsible for the acidic property. So whatever this is left, this is known as the conjugate base, right? So we have to see the stability. So here is a star point. Stability of conjugate base is more important when we see about the acidic strength. More stability, more acidic will be the compound. Similarly, when we talk about the basic strength base, we see we have to convert base into conjugate acid. Okay, we have to convert base into conjugate acid. For example, we have NH3, right? NH3 will accept H positive to form NH4 positive, right? So this is our conjugate acid over here, right? So conjugate acid. So we have to take in consideration of the stability of conjugate acid to tell which is the stronger acid. Okay, so let's get started with our question then. See, the first thing, the first option you can see here, we have, if we talk about option A, we have HCOOH. It will give out one H positive to form HCO negative, right? And then we have CH3COOH, and it will again lose one hydrogen to form this O negative. And then we have a bigger group than that. Okay, and we have COOH. It will lose hydrogen again to form CH3, CH2, C double bond O, and this negative. Okay, so we know that our methyl group. Okay, this we have to see the stability of this, in which structure this negative charge is more stable, that will be the more acidic one. Okay, so we know CH3 or any methyl or any R group, it has the property of plus I effect, means it will give the electron, it is electron donating group. Okay, so it will give the electron, while when we talk about C double bond O, it has the property of electron withdrawing. Okay, we call it as electron withdrawing group, right? So what we'll do, the CO is common, so we will not take it in the consideration because it is similar in all. We will see what part is different. See, here we have H doesn't have any plus I effect. Here we have methyl group, and here we have ethyl groups. Okay, so our plus I effect, electron donating group, increases when we increase the size of a group. So you can see that this will again give out the electrons in this direction. There will be more negative charge. Okay, more, it will not be stable, but they will increase more and more negative charge on this oxygen, right? So I'm writing it over here in this direction. Okay, so when we talk about this, it will give out the double amount of negative charge to this oxygen, right? So if you see here, they have not adding up to the negative charge. So when we take in consideration, if we call this 1, 2, 3, okay, so we know if we take it in the order, we have the A is more stable than this first is more stable than second and third. Okay, this is the order, and acidic order will be the same. Okay, acidic order will be the same. So if we see our option A, it is given the same size, it's given the same composition. Okay, first one is greater than second and third. Okay, so our A is the correct option. When we go to our B option, B we have fluorine, COOH, we have chlorine, COOH, we have bromine, COOH. Okay, so what will be the conjugate base for these? It is very simple now for you, I think. It is FCOO negative, Cl, COO negative, Br, COO negative. Okay, so see, the similarity is again this group, whole group is similar, only this halo compound is different. So what happen is, in this stage we can see that our this group is more stable than this one and this one. How? Because these will have the more chlorine is more electronegative than chlorine or bromine, right? Chlorine or bromine. So if there will be exerting any electron density, this chlorine will give out more and bromine will give out more than chlorine, and fluorine will give it will but it will give in the lesser quantity as compared to the chlorine and bromine. So if we take in the consideration here 1, 2 and 3, again we have 1 is greater than 2 and greater than third. Okay, so if we check our option, see our options are matching with the option given. Okay, so now for the option number C, we have this phenyl group and we have CHO, we have phenyl, CHO, and then we have, I think, OH. Okay, OH, then we have here PHOH again, and then we have, I think, ring, cyclohexane ring with OH, cyclohexane ring with OH, and we have to tell the acidic property, right? So what happened here is, see, if we consider this CO group, we know it is electron withdrawing, right? Electron withdrawing, and when we talk about pH is nothing but it is the benzene ring. Okay, benzene ring, and we have all studied about the resonating structures, that whether if we have this if we have any electron over here in this place, this will take part in the electron in the resonance. Okay, this side it will go and it will be doing delocalization. So we can say this benzene is having the electron withdrawing nature also. This benzene and this OCOH, it will have both electron withdrawing nature. So if we made the conjugate base, it will be something like PH, C double bond O, O negative. This will be PH, O negative, and this will be this cyclohexane, O negative. So you can see here 2 electron withdrawing groups, here 1 electron withdrawing group, and here if you see this will be giving electron density, right? So because these are just R groups, these are nothing but just R groups. So you can see over here the electron density is greater here in this one option, because due to the R group we have 2 plus I effect, right? And this phenyl group is again 1 electron withdrawing group, but we have here 2 electron withdrawing groups. Okay, so this one wins. So if we call this 1 with 2 with 3, and then we, again 1 is greater than 2, again greater than 3. This is in the terms of stability as well as the acidic property, right? So if we see our option number C, yes, this is the right order given. So this one is also correct. Now, if we go to the option number D, what we have a phenyl group with amine, we have cyclohexane with amine, we have this amide group. Okay. And we are having this D. We have phenyl with amine, right? Yes. Okay. Phenyl, amine. We have cyclohexane, amine. We have phenyl, then C double bond O, and then this is amide. Okay, this is not amine, this is amide. All right. So what do we have here is, yes, it is right. Okay. So we have, these are the bases and we have to form the conjugate acid. So conjugate acid will be something like PH, NH3 positive. This is cyclohexane, NH3 positive, and this is our amide, NH3 positive, right? So what happened here is, see, if you see in this group, what is happening, we have pH. We know pH is electron withdrawing group. It is already electron deficient. It doesn't have any extra electrons. It indeed needs extra electron to be stable, but pH is already withdrawing electrons, so this is not helping. So this will not be the stable one. Okay. And if we talk about this group, with this here we have two electron withdrawing group. Okay, but we need here electron donating group, which can donate the electron and stabilize the positive charge and convert it into negative charge, okay, or the neutral one, to make it stable compound. Okay, so here we have two electron withdrawing groups, here we have one electron withdrawing group. These both structures are not stable. Okay, when we talk about this group, these are something similar to this one, R groups. Okay, these are nothing but R groups. So R groups have plus I effect. Plus I effect means electron donating groups, electron donating effects, you can say. Okay, so here it is having two groups which are donating its electron to stabilize the positive charge. So if we call this 1, we call this 2, we call this 3, our second will be more stable than 1 and the third one will be least stable. Okay, and this is also the basic property of this series. Okay, now let's check our answer. They have put it wrong. They have put the second one after the first one, so this option is wrong option, right? So what are our correct options? Our correct options are A, B, and C are our correct options. So this was the solution, guys. I hope you understand it. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.